Let's share another example for the power series, which is the extended power series solution. Extended power series solution. The example is a second order ODE, linear ODE with variable coefficient, which is 8x squared y double prime plus 10xy prime plus x minus 1y equals to 0. And as we mentioned before, the first step, we want to rewrite this second order ODE to be the highest differential term with the coefficient to be 1. So first step, let's rewrite with y double prime coefficient to be 1. Okay, so that will be y double prime plus 5 over 4 divided by x, y prime plus x minus y, 8 times x squared y, that is equals to 0. And when the x equals to x now equals to 0, the bx is equals to 5 over 4. The cx equals to x minus 1 divided by 8, so that it can be analytic. It's analytic. It is the coefficient bx and cx is analytic. We can use the extended format. Therefore, our x solution will be the sum from m a m x to the m plus r term. So this is the extended form. Because bx and cx at x equals to x not equals to 0 is analytic. Okay. Then the second step, we will get what is the y double prime, y prime using the power series. So get y prime, y double prime using power series. Okay, so y prime, yx equals to sum m to the infinity, m equals to 0 to the infinity, am x to the m plus r. Y x prime will be equals to m from 0 to infinity, m plus r times am x to the m plus r minus 1. Y double prime will be equals to sum from 0 to infinity, m plus r times m plus r minus 1, am x to the m plus r minus 2. Later, what our final goal is trying to get the format of this yx, right? That means we need to get what is the coefficient am as well as what is the r part. So we will use this extended form to get our final solution set for the second order ODE. And this is a homogeneous equations. That means the general solution will only have the homogeneous solution type. And we are trying to get what is R, what is AM, okay? Then the third step, after the analysis, what is our Vax prime, Vax double prime, we just put this power series format into our original ODEs, okay? Our original ODEs. Then the third step is put y double prime, y into original ODEs, okay? And that leads to our 8 times x squared y double prime, okay? Well, we 8 sum from m equals to 0 to infinity, m plus r times m plus r minus 1 am x to the m plus r. Okay, the second term is 10xy prime. That will be plus 10 m from 0 to infinity, m plus r, am x to the m plus r. Then the final term is x minus 1 times y, okay? So that will be plus sum from m equals to 0 to infinity am x to the m plus r plus 1 minus 1 y. So it's from 0 to infinity am x to the m plus r equals to 0. So this is the term after I put all the differential terms itself into the original format with the power series format. Okay. And then what is our fourth step? So the fourth step is the most important step, is basically we want to make our exponential part. So the fourth step is the most important part for power series. It's shift all the term to the highest exponential. What is our highest exponential in this term? The highest exponential is here, x to the m plus r plus 1. So x to the m plus r plus 1. Shift all the term like this. And first, the sum part, which is m start from m equals to 0. So shift all the terms to the highest exponential term. For this case is x to the m plus r plus 1. And force the sum part, which is m equals to 0. And start with the sum from m equals to 0. Then how we do for this case? Okay, so we just make all the coefficients together and then trying to see how we can shift. So if you can see here, let's just make all the terms coefficient to x to the m plus r together. All the coefficients for x to the m plus r plus 1 together. So the sum from 0 to infinity, 8 m plus r minus 1 am plus 10 m plus r am minus am, okay, times x to the m plus r term plus from 0 to infinity am x to the m plus r plus 1 equals to 0. So that we can just put all the coefficients for x to the m plus r together. The other is the m plus r plus 1. Okay. And we see that this term is already satisfied for the first step, where that highest term is m plus r plus 1. It starts from m equals to 0, but we need to change for the first term. Okay. So how we change the first term? We make the m will be equals to p plus 1. Okay. So p will be equals to m minus 1. If we can make this p plus 1 plus r term, then later if the p starts with 0, then we still satisfy for our first step. Let's see after we substitute m equals to p plus 1, what will happen. Okay. So it starts from p equals to minus 1 going to infinity, and 8 times p plus 1 plus r times p plus r times ap plus 1 plus 10 times p plus 1 plus r times ap plus 1 minus ap plus 1 to the x to the p plus 1 plus r term. Okay. Then let's just separate to p equals to minus 1 and then p equals to 0 and zeros were above. So when p equals to minus 1, what this term equals to? That will be 8 times r, right? So it's 0 plus r is r, and r minus 1, a 0, okay? Plus p equals to minus 1, that means 10 times r times a naught, minus A naught times the overall A R. Okay. Right. Then what we get for P equals to minus one term? P equals minus one term will be equals to AR squared minus AR plus 10R minus 1 times A naught times A to the R. Sorry, X to the R. X to the R. And this part will be A squared, 8R squared minus plus 2R minus 1 times A naught X to the R. And we can write this as 4R minus 1, 2R plus 1, A naught X to the R. Okay. So this is P equals 2 minus 1 term. Then everything can shift from P equals to 0 to infinity with all this term. So the first term can write as, the first term can be write as the sum from P equals to 0. You can write as, P equals to 0 to infinity. 8 times P plus 1 plus R times P plus R, AP plus 1 plus 10 times P plus 1 times R, AP plus 1 minus AP plus 1 times the overall X to the P plus 1 plus R. That is since P equals to 0 to above. And that is, you can just rewrite this P as any integers. It can be M. So M from 0 to infinity, 8 times M plus 1 plus R times M plus R, A to the M plus 1 plus 10 times M plus 1 plus R, A M plus 1 minus A M plus 1 times X to the M plus R plus 1. And you also need to add this P equals to minus 1 term. So it's plus this 4R minus 1, 2R plus 1 times A naught X to the R. That is the whole term represent for the first part. And you also need to add this part. So plus sum of from M equals to 0 to infinity, A M X to the M plus R plus 1 equals to 0. So we rewrite our original ODE into power series format, and we shift all the highest term to be M plus R plus 1, okay? All the term for the sum. And also the sum start with M equals to 0 to infinity, okay? So the first step done, Then we basically need to see what kind of M and R and A coefficients can make these equations to be 0, right? To be 0. So that is our next step, trying to figure out the A coefficient with R and with R. Trying to figure out our A coefficients and R. And for this system to be equals to 0, we will have that when we have, let's try some numbers, trying to see is there any relationship between the AM plus 1 and AM. Okay, so